Today we have started with the uh, first theorem, and I will just take a brief review of this because now the theorems are more important and that requires more understanding. So the first thing what I discussed with you was regarding the linear elements, because or in other words the linear circuits, because all these theorems are applicable to the linear circuit. And there we discussed what do you mean by the linear circuit. So linear circuit is nothing but the circuit which includes, it consists of the linear elements. So what is mean by the linear element? It may be a resistor, it may be an inductor, or it may be a capacitor. All these elements now we consider as the linear element, because for any element, if you give the input, it has the response, that is nothing but the output. So the output of this element and the input of this element, if they are related by some particular way, then we say that they are linear. For example, what I said there, that if you take the resistor, now if I apply the voltage across the resistor and take the current through the resistor as the output, then if I change the input, that is the voltage, by some multiplying factor, I may make it half or I make it double or triple, then the output, that is the current, also changes in the same proportion. When I make the voltage double, we discussed that the current also becomes double, and therefore there is a definite relationship and they are directly proportional to each other, and therefore these elements are called as the linear element, and that circuit is called as the linear circuit. Now we discussed with the superposition principle, and I have given the statement. The statement is nothing but the way that we solve the example. So the concept of the superposition principle is that whenever we are having the linear electrical circuit and we are having many more sources, more than one, that is two or more, and then each source is contributing the current or a voltage through the resistance or across resistance, and that voltage or current, that is the response of that source, is nothing but the algebraic addition of the contribution of each source acting alone. And therefore here whatever may be the number of sources, we consider them one by one, and then in that case we find out the response given by each of this. And while doing this, now we turn off all the elements, all the sources, except that one which is acting alone. While turning off, one care has to be taken that whenever there are voltage sources, then we have to make the voltage zero, and obviously the voltage source voltage can be made zero if we make it short circuit. And the same thing for the current source, we have to make the current equal to zero of that source, then in that case we have to open circuit that current source. So this turn off method has to be remembered. And one more important thing is that we have to make the change of independent sources. Dependent sources are not to be removed even in one source acting alone. And then you consider one by one source and then calculate, you find out the voltage or current in the given branch, and by using any method that we have learned, and then at the end you add those responses, those voltages or those currents algebraically, taking into consideration the sign of this or direction of this. Now, in short, I will just discuss the same example because this is a good example which consists of all kind of sources. So I have considered the voltage source, at the same time I have considered the current source. I have considered the independent source, and also I have considered the dependent source. And therefore, here in this example, that I hope it will make the clear most of your doubts. So here in this case, now we are having these three sources. Two are independent and one is dependent. So in this case, now here you can consider this one by one. So in this case, now here I have considered these sources as acting alone each time, and let us say that each of these supplies the current as I0 dash and I0 double dash. So here let us say that I0 dash is the current which is supplied by the 4 ampere alone, and I0 double dash is the current which is supplied by the 20 volt source alone. Now remember, as this is a dependent source, that we will not remove this for the calculation when each source is acting alone, and therefore in the first step we will start with I0 dash. So let us say that I0 is the current due to the contribution by the 20 volt as well as by the 4 ampere, and therefore it is the addition, algebraic of course, that is the addition of the currents I0 dash and I0 double dash. That is the equation 1. So to begin with, now we turn off the 20 volt source, and when we have to turn off the 20 volt source or voltage source, then we have to short circuit the voltage source. We have to make the voltage of that source as a 0, and therefore we will make a short circuit. That has to be remembered very well. So in this case, now as we are having only one source acting, and this will be kept as it is because it is a dependent source, so we will not make any change. When we are considering the dependent source, the another thing care you will have to take is that in this case, now it depends on this value of the current I0, or in earlier figure it was given phi I0, and I0 was marked here, that was the current through this 5 ohm branch. But in this case, now we are changing the circuit. I am assuming for my simplification analysis purpose that for the time being, let us say that only one current source 4 ampere is acting in the circuit, and then what will be the response, what will be the current through this. So while doing so, then the current through this 5 ohm resistor is going to change, obviously, because it is the only current contributed by 4 ampere. This source is not present now, and therefore this current will be called by the other name, and therefore I will call this as a I0 dash. And when I am talking this as a I0 dash, then obviously this current which depends on this branch current, and therefore that also has to be changed, and therefore it will become phi I0 dash. So once that is understood, the rest of the things are simple. What is that? In this case, now here we have to make use of any method that we know. So here, what is the ultimate aim? The ultimate aim is to find out the current through this. That is the response, that is the current flowing through this 5 ohm resistor because of this 4 ampere. So I0 dash has to be calculated, and here you are free to make use of any method that you know. So here I will be making use of the mesh analysis, and therefore I have written the equations for this mesh analysis, that is loop 1, loop 2 and loop 3. So for loop 1 there is only one current source on this side, so I did not worry about that. In fact, it has helped us to find the current for this I1. So I1 directly available as 4 amperes because they are in the same direction. For loop 2 and loop 3 you have written the equation, and now here in order to reduce the number of variables, so that I have to calculate, I have to solve less number of simultaneous equations to find out the answer. Therefore here now I will make use of KCL. So here now I make use of KCL at the point node O, and therefore I can write the KCL, and I will eliminate the number of variables. In fact, I0 dash I will retain as it is because I have to find out the value for this I0 dash. So when you solve these equations, we get I0 dash as 3 amperes. That is the equation number 8. Now here, one step ahead. So when you consider now the next source, that is 20 volt source acting alone, and this 4 ampere source has to be removed, that is turned off. So here it has to be made open circuit. So I0 dash is now the current which is only contributed by this 20 volt source. So here dependent source has no responsibility as such for the contribution of this because it depends on the internal factor. So it is not separately supplying the current for this. In fact, the value of this depends on this current. When there is no current here, so there is no source here. It is not like that. So 20 volt will be always there, even though you have not made any changes even though there is a circuit connected to this or not, 20 volt, that is the EMF of this source, will be always there. So here this I0 dash, let us say that this is the current now only because of this 20 volt. So if now we have to find out this, then again we consider the mesh analysis as I4 and I5. Then again we write the KVL equations for this, and then we take the help of this, that I5, that is nothing but this current, and its current is nothing but the I0 dash. The only thing that it is opposite in direction, and therefore it will be minus I0 double dash. So if you put that value in the earlier two equations, then we get new two equations, and we solve this two equations to find out I0 double dash, and we find here I0 double dash as minus 3.53 amperes. So I remember at the end of the lecture I was confused. So here in this case, because at the addition of these two I had written as minus, and none of these two, I0 dash and I0 double dash, both were positive. So I rechecked the calculation. So here you can remember, while writing this in the equation editor, now we have to concentrate a lot, and this minus was not typed there at that time. So I found it, and therefore this value is minus 3.53. So if you add this with the earlier I0 dash, then we get this answer. So I found it that to repeat it, because it was essential to know the all the intricacy of the problem. This problem I had given for the homework, and answer for this I tell you that it is 2 minus 1 and plus 1, because now here there are three sources. So there are three sources: 24 volt, 12 volt, and 3 ampere. So you will have to repeat this problem three times. These are all independent sources, so every time we have to consider each acting alone. So for example, only 12 volts is acting alone, and this will be short circuited and this will be open circuited, and then find out the current. Then in the next step you consider only 24 volt. Then in that case you make short circuit this and open circuit this and find out this current. So you can say I1 for this, I2 because of this, and then I3 because of this. And then just write the equation, algebraic equation, that is the addition of all the three currents with the sign, and then the final answer you get is 2 amperes.